Now let us see how do we calculate the variance. So for the population, the notation for variance is this: sigma square. This is equals to first observation minus its mean whole square plus second observation minus its mean and whole square all the way to the nth observation xn minus mu whole square, and we divide it by n. So this is what we mean by the variance, and this is how we can calculate the variance for population. So let me write it as xi minus mu whole square, and we take the average of this one, where n is our population size. So for the sample, the notation is now s square, and the formula is similar. First observation minus its mean square plus second observation minus its mean square. The deviation from for each observation, we take the deviation from its mean, v square, and we take the sum of it all the way to n observations. So it is xn minus x bar whole square, and the only difference is that we divide it by n minus 1, because this gives us the unbiased estimate of the true population. And in sigma notation, we write it as summation xi minus x bar whole square divided by n minus 1. Here, where I is equals to from 1 to n for the population, and for the sample, I is equals to 1 to sample size n. The population sample, now let us deal with the case of frequency. And let me write it again for the sample. We are going to treat it for the sample simply. In this formula, we add the frequency. So f1 x0 minus x bar whole square plus f2 x2 minus x bar whole square, and then a frequencyfen xn minus x bar whole square, and we divide it by n minus 1. This is no different. And in sigma notation, we take it from 1 to n, and here is xi minus, we have frequency of xi minus x bar whole square, and then we divide it by n minus 1. This is again very simple. Now let us deal with the case of probability, and the notation, we write it as variance x. Variance x is equals to, it is p1, and then we have x minus expectation of x and its square. First observation x1. For the second observation, it is p2, x2 minus expected of x, its whole square, all the way to pn, and then xn minus expected of x, its whole square. And this can be written in terms of sigma notation as I is equals to 1 to n, probability of xi minus expected of x, its square. No need to divide it by anything. So this is it. Now, in case of TIMU as continuous variable, okay, let me write it as s square again, or we can write it as variance x, or let me write it as a variance of x, and this is similar. We integrate from lower bound to upper bound, and then ex minus expected of x, or we can write it as x bar, its square, the deviation from the mean, and its square, and we are taking the sum. And let us assign the probability that is equal to function x, change in x. This is equivalent to the same results. Integration is equivalent to summation, and this deviation fx is equals to probability of I all the way to this value xi, expectation of x, and its square. So the deviation from the mean is square for each observations, and we multiply it by the probability, and we take the similar sum all the way to n observation. Now let us for variance, in case of matrix notation, let me write it as variance of variable x.